Hi everyone, welcome to this video on lesson 14 of the variation and inheritance scheme of work. And this is just, I think this is a wonderful lesson and it's a wonderful theory, obviously, one of the greatest theories any human being has ever come up with. So it's a really nice one to teach, but it's also a really challenging theory. It's really hard for students to get their heads around it to the point where we really want them to actually understand what's going on here. And that is a challenge. But the way I would frame it is to go back to what we studied in an earlier lesson on variation. And we're coming back to Darwin's finches. We don't necessarily need to do finches, but they're such a famous example that actually it makes sense to just carry on with that. And actually it's quite an easy one to frame to students. So what I'm going to do, and again, don't just use the visualizer for this. I think the visualizer is really helpful in laying out certain things, but also make sure you show lots of pictures and videos where you think that's appropriate, just to make things more concrete. Once you've done that, then you can go to the visualizer and start to say, okay, let's look at what's going on here. We know that there is variation between finches, and I've really exaggerated this, but let's say we've got these two finches which have kind of similar shaped heads, but this one's got a long beak, this one has got a kind of shorter, fatter beak. Why is that? What's going on here? And the history in this lesson is interesting. It's not strictly necessary. So if you choose to leave that out, that's absolutely fine. But essentially, so this is planned by Naomi, lead practitioner for science at Homely Park. Her and I have had some discussion about this, which I'm not sure we've quite resolved about who said what in terms of Darwin and Gould, but the point is that there's kind of two ways of thinking about this. So you've got these two finches. You can either think, okay, these are separate species. And what I'm going to do is kind of divide my page, if I was explaining this to students, into two. And I'd say there's two ways of thinking about the variation that we've got here. One, to use a similar language to what we used in the previous lesson on Lamarck. One is this kind of religious way of thinking about it. And the religious way would be to say the reason these two types of birds, I'm going to use types just because that's a fairly plain word, the reason these two types of bird are different are because of creation. And again, I'm not sure a diagram of creation is very helpful here, but the point being, the reason these two are different is that they were created different whenever that was, 4,004 years ago or how many years ago it was, and therefore they are different species that have been different since time began. So different species. And this is how a lot of people thought at Darwin's time, that the reason they're different is because they're different species and therefore that's just how they are. That's all there is to it. What Darwin realized, and again the story with Gould is that Gould, between them they thought, well, hang on, maybe these are variations within a species. And then Darwin started to think, well, okay, if there's variation within species here, and that depends on the island that these finches are on, oops, Darwin, Ian, then hang on, maybe there's an alternative explanation here. So what we're going to do is contrast this idea of creation, that the species were created and then they were fixed, they just stayed as they were forever. We're going to contrast this with the idea of evolution. So obviously this is a really, really important word, and we want to flag that. And I think the main thing to draw students' attention to is what we mean by evolution is to say this is evolution from a common ancestor. And we're going to illustrate that with some diagrams below here. But evolution from a common ancestor, i.e. these two things probably started out in the same bird. But what happened was somehow that variation developed, and you can draw students' attention to Darwin's tree of life and so on, but somehow these differences developed so that then you had these two birds on different islands that looked really, really different. So how did this happen? Well, what I'm going to do below here is try and illustrate this in really, really simple terms. So let's imagine this common ancestor, something that looks like this, and I'm going to draw the common ancestor as a bird with a relatively short, fat beak like that. And what we can do is say, well, okay, let's look at what happened when these common ancestors were situated on different islands. So I'm going to draw one island like this. I'm going to do a kind of very classic cartoony desert island here. I'm not even going to attempt to draw palm trees because my artistic skills are not good enough. But we've got these two islands here, and we can say these are islands in the Galapagos, something like that. That's absolutely fine. Now this island is sandy, so there's not a lot going on here. Maybe a few trees, but not too much else. Whereas this island is covered in rocks. So I'm going to draw these rocks here like this. And this is why it's really important to build up this picture with students, tell them this story. This island is covered in rocks like this. So I've got this sandy island and an island covered with rocks. So let's imagine we've got some of these birds with short beaks on this island that's sandy. Well, if I draw my three birds like this, or some eyes too like that. On this sandy island, well, here are some worms. I don't know whether worms live in sand, but I'm just telling a simple story here. Here are some worms. These three can all get at those worms. They're all going to be able to survive, no problem. So all of these three are going to survive. So what you're going to get on this island is just more of the same. You're going to get more of your common ancestor. So what I'm going to do is then draw this again here like that. Shouldn't have made that fatter really. That should just be the same as the original one, but hopefully you get the idea. This bird can survive on here, no problem. But let's imagine on the rocky island, where actually the worms are kind of hidden between these very thin cracks in the rocks like this. They're much harder to get at. Well, let's imagine we've got a few of these birds, and two of them are like the common ancestor with the short fat beaks. So let's draw another one like that. Now there's going to be a problem here. These two are not going to be able to survive because their beaks aren't long enough to get between the rocks to get at those worms that they want to eat. But then for whatever reason, we had variation within the species. One bird was born with a longer beak like this. And what we want students to recognize is that this bird that was born with the longer beak, and again, we don't have a mechanism, we're not talking about mutations in DNA and all of that sort of stuff at this stage. We're just saying we know that we get variation within species. This is the bird that's most likely to survive. And therefore, and again, this is where you can go back to lesson 12, a couple of lessons ago about selective breeding. Over many generations, if birds with longer beaks are more likely to survive, well, over many generations, what's going to happen is that they're the ones that are most likely to reproduce. And therefore, what you're going to see on this island is these birds with exaggeratedly longer beaks like that. So we can see this is analogous to the selective breeding that we talked about when I did a video on XL bullies, and there were lots of other examples to do with cauliflowers and kale and things like that. We can see that there's some process of selection going on. And this is, I mean, I didn't really understand this, I'm not going to lie, until I was reading through Naomi's resources. I think they're absolutely brilliant. But when we talk about natural selection, there's a process of selection going on. And what we want to do is draw students' attention to the fact that it's not like selective breeding, breeding XL bullies or cows or racehorses or pigeons or whatever. It's not like selective breeding where a person is doing the selection. Who's doing the selection in this case? It is nature. Nature, the fact that there's rocks there, nature therefore selects for these ones to survive and these ones not to survive. So what's happening here is that it's nature that's doing the selection, and that's why we call Darwin's theory natural selection. And I'm going to draw students' attention to the fact that where I've done these ticks and crosses, this is what we're going to call natural selection. And the reason it's called natural selection is because nature is selecting the organisms with the desired characteristics to survive, and therefore over many generations these are the ones that end up being observed. So this is a completely different explanation of why we have the variation that we saw in the beginning with the finches. So if I just move this up here like that, hopefully that's clear. This is not like the creation explanation where we say, well, they were just formed differently, and you know, the maker in their infinite wisdom created a myriad of things, and yeah, they just happen to do different ones on different islands. What we're saying now in Darwin's theory is actually they did start out the same, but because of the different environments, different ones were selected by nature to survive, and that's a really profound leap forward. What we're going to do in the next lesson after this is build on this idea. So this lesson is about just introducing the theory with relation to something that they've seen before, i.e. Darwin's finches. What we're going to do in the next lesson is just practice this with multiple case studies, so students are really clear how to explain this thoroughly in words.